Subscribe and go beyond the obvious.
Imagine Mars not as the lifeless red desert we are used to, but as a blooming world with real rainforests, heavy downpours, and full-flowing rivers. Sounds like science fiction, but now we have solid evidence. NASA's Perseverance rover has discovered a unique mineral called kaolinite on the floor of Jezero crater. On Earth, this substance forms exclusively in warm and humid conditions where torrential rains fall for millions of years. This kind of rainfall feeds dense jungles, not dry wastelands. This discovery completely overturns our understanding of the red planet. It really did rain here once, and it lasted for epochs. That mysterious kaolinite couldn't have appeared from a brief flood or a melting glacier. Its origin requires a completely different scenario. Liquid water must have soaked the rock for an insanely long time, breaking it down grain by grain. When Perseverance recorded pebbles and boulders rich in this mineral scattered across the surface, scientists came to a stunning conclusion. The ancient climate of Mars behaved less like cold Antarctica and more like the humid Amazon. This tells us that in the distant past, Mars possessed an incredibly stable climate. It had a thick atmosphere capable of retaining heat and a fully functioning water cycle with clouds, rain, and surface runoff. Jezero crater itself, where the find was made, is a unique place. It used to be a massive lake fed by powerful rivers. Their channels, carved by water into stone, are still clearly visible from orbit today, resembling scars from the planet's past life. Scientists believe that ancient rivers could have worked like a giant natural conveyor belt, washing kaolinite-rich soil from tropical forests right into the crater basin. There is also an alternative theory. Perhaps a massive meteorite impact blasted this material from neighboring regions and scattered it here like cosmic shrapnel. But whichever scenario turns out to be true, one thing is obvious: water moved these rocks. And the very fact of moving water is a huge deal, because stagnant bodies of water are simply incapable of shaping a landscape in this way. Every form of life we know, from the simplest bacteria to humans, depends on liquid water. Not ice, not vapor, but stable moisture that sticks around on the surface. A warm and wet Mars with regular rainfall would inevitably have had a network of streams, wetlands, and an environment for continuous chemical reactions. These are exactly the ingredients that sparked the origin of life on our own planet billions of years ago. This doesn't necessarily mean that complex creatures were wandering ancient Mars waving at the sky. However, the planet checked far more boxes for potential habitability than we ever expected. For decades, Mars looked to us like a world that lived for only 5 minutes on a geological scale and then froze forever. Now, the picture has changed. We are looking at a world that remained comfortable and hospitable for hundreds of millions of years before everything went wrong. Scientists believe the catastrophe began the moment Mars lost its global magnetic field. Imagine this field as an invisible planetary shield. Without it, the planet was left completely defenseless against the solar wind, a relentless stream of charged particles flying from the sun. This cosmic storm slowly but surely stripped away the atmosphere layer by layer until it left the planet naked and freezing. But while headlines scream about ancient rainforests, Mars keeps throwing curveballs. In 2025, researchers discovered so-called skylights on the red planet. These aren't just craters, but giant vertical holes leading straight into vast underground cave systems formed in the distant past. These pits open a door to an underworld hidden from view for billions of years. On Earth, caves like this serve as shelters, protecting all life from deadly radiation, wild temperature swings, and surface chaos. If life ever existed on ancient Mars, these underground spaces would have been the perfect hideout. Some of these caves might be karstic, meaning they were created by slightly acidic water that patiently dissolved the rock, carving out underground halls. This process requires liquid water and immense patience, both of which Mars apparently had plenty of back in the day. Scientists suspect that these caves could act as perfect natural safes. They are capable of trapping ice, preserving chemical fingerprints of life, or even locking away organic material untouched for billions of years. It's like a time capsule that no one has opened yet, sealed by the planet itself. Inside, a history that the surface erased long ago with winds and radiation might still be hiding. These mysterious sinkholes are located in a region known as Hebrus Valles. This place is tucked between an old volcano and a massive plain in Mars' northern hemisphere. Interestingly, there are no signs of lava tubes here, which scientists have known about for a long time. Instead, the terrain literally screams water, ancient riverbeds, hydrated minerals, and sedimentary rocks that could only form if water stuck around here for a long time. Researchers identified 8 of these skylights and immediately ruled out meteorites. These are definitely not impact craters because there is no characteristic rim of ejected debris around them. Nothing splashed outward upon impact. The surface simply collapsed into the void below, revealing an entrance to the underground. Researchers pieced this story together using old mission data, hydrogen maps pointing to hidden water, and ultra-sharp images from orbit. The main feature of these caves is protection. They block cosmic radiation, trap ice, and preserve chemical traces far better than any open surface ever could. If Mars was ever home to life, even simple microbes, these underground cavities rank among the top places to look for remains. There, in the dark and cold, the planet's history could be preserved in its original form. Now, let's rewind a bit to July 2024. The Perseverance rover was making its way along the bottom of what used to be a turbulent river billions of years ago. After the water dried up, part of the rock face broke off and fell into the dry channel. The rover stumbled upon this debris, which had lain there in complete solitude for an eternity. Scientists named this unique rock Cheyava Falls. Upon closer inspection, the rock's surface turned out to be covered in tiny dark dots, which scientists affectionately nicknamed poppy seeds, and larger light blotches with dark rims, so-called leopard spots. But the most interesting part began when Perseverance deployed its instruments. It detected organic molecules. These are carbon-based compounds, the very basic ingredient that every living thing on Earth uses. Years ago, astrobiologists predicted that if microbes ever existed on Mars, they would leave exactly these kinds of traces in the rock. These spots are the key to the puzzle because all life needs energy. Earth plants get it from the sun, but many organisms literally eat chemistry. Microbes can survive by moving electrons from one chemical substance to another, as if they are stealing a charge from spare batteries to sustain their existence. In the case of the Cheyava Falls rock, scientists suspect the following scenario. Ancient Martian microbes could have taken electrons from organic compounds and handed them over to iron contained in the rock. This reaction releases the energy needed for life. And here is where the chemical detective comes in. The dark dots and rims contain a mineral called vivianite. On Earth, it forms only in one case, when iron is reduced, meaning it receives those very electrons. When iron undergoes this transformation, it loses its usual rusty red hue and turns pale. This explains why the centers of the leopard spots look light, while the edges are dark. In addition to this, Perseverance found another rare mineral there, gragite. Sulfide is needed for its formation, and microbes are known masters of producing sulfides. They create them by feeding electrons to sulfates, which were also found in this rock. Unfortunately, right now scientists can't fully analyze this rock. The rover's instruments have their limitations. However, technologies already exist on Earth that can see the invisible. If microbes ever lived in Mars' ancient oceans, they likely didn't leave skeletons or bones. Their legacy is chemical fingerprints securely locked inside minerals. And to find them, you need to know exactly where and how to look. On our planet, microbes appeared in the oceans about 3.7 billion years ago. At that same time, Mars was rich in water. When water evaporates, it leaves behind salts and minerals. Some of them are capable of trapping microorganisms and preserving them forever, like prehistoric insects in amber. Scientists are betting that on Mars, sulfate minerals played this role of a preservation tin. On Earth, gypsum serves as an analog for this preservative. To test this theory in practice, a team of researchers went to a gypsum quarry in Algeria. Millions of years ago, the Mediterranean Sea almost completely dried up, leaving behind thick layers of this rock. These layers became a trap for ancient bacteria, turning the Algerian quarry into a perfect testing ground that simulates Martian conditions. To analyze these samples, the team used a compact device with the formidable name LIMS, Laser Ablation Ionization Mass Spectrometry. It sounds complicated, but in reality, it works like a high-precision laser sniper. The beam hits a tiny point on the rock, instantly vaporizes the material, and then the device reads the composition of this vapor, like scanning a barcode in a supermarket. This allows scientists to see the unique chemical composition hidden inside without destroying the rock itself. When this laser was aimed at the Algerian gypsum, the results were stunning. Scientists discovered thin, thread-like structures that were unmistakably identified as ancient bacteria. But more importantly, they found specific minerals, such as dolomite and certain types of clay. These aren't just random rocks. They are substances that microbes help create during their life processes. This proves that life doesn't just leave fossils behind. It fundamentally changes the chemistry of the rock it inhabits. However, applying this knowledge to Mars is a challenge of a completely different level. Fossils there would not be millions, but billions of years old. The environment there is alien, harsh, and confusing. Scientists need to be 100% sure that they are not mistaking ordinary chemical processes that simply mimic biology for life. Robots are doing a great job, but many experts are convinced to find the final answer and dot all the I's, we will have to send the most advanced research machine in the universe there, a human. And that is why priority number one for the first manned mission to Mars is the search for life. Forget about mining rare resources or planting flags for beautiful news shots. Scientists need to know the truth. Was Mars ever inhabited? Is someone living there right now, hiding in deep caves? Or did the planet simply start the complex chemical reactions that lead to life, but stopped halfway, never completing the experiment? After answering this main question, researchers want to understand the planet's mechanics. Where did the water and carbon dioxide disappear to? How did these cycles work in the past, and how did they change over time? Geology plays the role of memory here. Rocks store the planet's history like a hard drive. Each layer of sedimentary rock is a recorded chapter that needs to be read to understand why Mars became the way we see it. And finally, we need to find out how Mars affects us. How will the human body, brain, and psyche behave in conditions of total isolation and low gravity? Will Earth crops be able to grow there to feed colonists? How will cosmic radiation affect our DNA? And is safe reproduction even possible beyond Earth? And also, do Martian microbes, if they exist, pose a deadly threat to astronauts? These are questions to which we have yet to find answers. That's all for today. If you found it interesting to dive into the secrets of the red planet, like this video and share it. See you soon.